Hello everyone, and good evening, and welcome to episode number 8 of our project discussion series, which you all know uh, is an online platform for us to discuss projects and to share our ideas, experiences, and problems. So, good evening to everyone. And this is the first time that we are meeting this month. We could not conduct an episode earlier in the month this time. So, in the month of November, this would be the first episode that we are conducting. I hope my voice is properly audible. Yes. So, before we move ahead, today is an unfortunate day in the history of our country. So, let us take a minute to remember the people who laid down their lives in defending our country on this unfortunate day on 26th 11 2008. So we take a moment and we remember their sacrifice, who laid down their lives for our comfort. Yes. So continuing with our episode, as you all know that we in every episode we take up some problem, and then we take up an interesting project and what we did in that project, and then we learn from the experiences. So today, this time, the problem that we are going to take is actually not a problem, but it is a, I would say, a problem in the sense that we as a practicing structural engineer face this quite often and see this quite often. So what is that problem? The problem is that when we have to provide flat slab structures, how to provide flat slab structures with simple columns. So all of you know that flat slab structures cannot be provided just with columns, especially if you have to design them for lateral loads, at least in the Indian context. So that is a problem that we as structural engineers quite often face, and our code mandates that we have to provide shear walls, and whenever we are using flat slab systems we have to go for shear walls also, if you want to design them for lateral loads, especially the earthquake. So that is a big problem that we face. In such a scenario, what is the solution? What can we do? So I think all of you must have heard about SMRF, OMRF, special moment resisting frames, ordinary moment resisting frame. But have you heard about IMRF? Has anyone in the audience, has anyone heard about IMRF? So IMRF stands for the intermediate moment resisting frame. So there is a special moment frame, there is an ordinary moment resisting frame, and then there is an intermediate moment resisting frame. So this is quite an interesting structural system that you get in the American and the European codes. So the ACI code and the EN code allows you the use of a lateral load resisting system by the name of intermediate moment resisting frame. In the intermediate moment resisting frame, you have got two options. One is to have slab with beams and columns, and the other system that you can go with is slab without beams. So slab without beams, I think we all better know it as what? So we better know it as the flat slab or the flat plate system. So actually, the American code, the European code does allow you to use flat slab buildings with columns without shear walls in earthquake zones. All right. Unlike the Indian code, which does not allow you to use flat slab buildings without shear walls for earthquake zones, American code does allow you. So it does allow you by using an intermediate moment resisting frame system. If you see, uh, if someone can tell me we can use OMRF up to which seismic zone in Indian context, if I have to go with an ordinary moment resisting frame, I can use it up to which zone in the Indian context, as per the IS 1893. No, I should say as per the IS 13920. So if you know, we can go up to zone 3 for a certain height, otherwise up to zone 2, isn't it? No, in fact, zone 2 and zone 3 up to a certain height. That's what we can go with if we are using ordinary movement resisting frame. In zone 4, in zone 5 for certain heights. In zone 3 also we have to go for a special movement resisting frame. All right. But in this case, the system that I'm going to talk about now, the intermediate movement resisting frame system, you can use it up to a seismic design category C. So in the American scenario, you don't get zones like zone 2, zone 3, zone 4, zone 5. You have the seismic design categories B, C, D, E, and F. That is a more scientific system of classification, unlike the system that the Indian code has adopted, uh, which is not a proper system to classify. So if you see the intermediate moment resisting frames, I have highlighted it in yellow. You can use it in seismic design category B. In the last columns, you can see NL stands for no limit. So there is no limit, no height restriction for using an intermediate moment resisting frame in seismic design category B and C. No limit. And you are not allowed to use an intermediate moment resisting frame in seismic design categories D, E, and F. So NP stands for not permitted. So you are not permitted to use these systems in categories D, E, and F. So that means if you are going for a flat slab building and if you don't want to provide shear walls, you can in fact go for a flat slab buildings just with columns in seismic design categories B and C. Then, if you have to design your flat slab building in categories D, E, and F, then you will have to provide flat slabs with shear walls. I hope that concept is clear. Here, I must add that seismic design category C means a substantial earthquake. You could say in Indian context, up to let's say some parts of Deccan Plateau of India, large parts of the southern India, all these will comfortably fall under the seismic design category C as per the American code. So American code does allow you the use of this system. I think it is clear from the name that intermediate movement resisting frame would have intermediate ductility. Okay, so the ductility would not be as high as the special movement resisting frame and not as low as the ordinary movement resisting frame. So let us look at some detailing requirements for this IMRF system that is given in the American code. This is taken from the section number 18.4.5 of ACI 318. So let's quickly look at them. This is a simple flat slab plan that I have taken. 7 by 7 is every panel, and in fact it is without drops right now, just for illustration purpose. So whatever we would be focusing more on the column strips right now. Why column strips? Because middle strips anyway are not important for lateral load transfer as such. Most of the lateral loads from the diaphragm action will be transferred through the column strips. So I would be talking more about the column strips, and column strips we would detail them in a specific way to enable them to act somewhat like beams. Okay, so it would be the column strips that would be acting as you could say a beam element, transferring the lateral load to the columns below. So whatever moment, analysis moment, you calculate the reinforcement, and that has to be placed within the column strip width. That is what is written in this clause. I think most of you know the width of column strip that has to be taken. So column strip width has to be taken equal to 0.25 times the center to center distance between the columns in either direction, whatever is the lesser. So I have just pasted the clauses copied from ACI 318. You can refer to the clauses in detail by these numbers. So within this column strip, sorry, yes, within this column strip, you have to place all the reinforcement that is required as per your analysis moment. Then in this column strip width also, right now if you see the width is 3.5 meters. All right. My span is 7 meters center to center in either directions. So the column strip width will be 3.5 meters, half of it. Now within this 3.5 also, there is a specific width where more movements are concentrated. All right. You can see the figure. The same concept is in the Indian code also, taken from this very American code. So out of the total reinforcement requirement, you have to design the central portion, which is within a width equal to 1.5 times the slab thickness on either side of column face, for a moment which is equal to gamma f into the analysis moment. Okay, what does this mean? I'll just show you in the next slide. Same concept is given in the American code, in the Indian code also. So you see, I have marked an orange strip. So my column strip was 3.5 meters. Okay. Now in this 3.5 meters, I will demarcate this special width, which will come out to be equal to 1.25 meters. How this 1.25 meters has come? So I have to take from the column face a distance equal to 1.5 times the slab depth. So my slab depth was 250 mm, capital D, and therefore I get 375 mm on either side. You add to that the column width in that direction, so the overall width comes out to be 1.25 meters. So out of the column strip width of 3.5, I have to concentrate more reinforcement in this particular strip width. Why we have to do so? Because in this zone there will be a moment transfer from slab to columns. Okay, so this is what is written in this particular clause. So in this particular width, the unbalanced movement will be transferred from slab to column. Okay. How to calculate that unbalanced movement? We have to calculate this factor gamma f. The same formula is given in the Indian code also. Exactly the same formula. So gamma f gives you 0.637, where B1, B2 are the dimensions of the critical perimeter. And I think all of you know the critical perimeter for punching. So effectively, this means that out of the total moment, 0.637 moment, you have to provide reinforcement for this much moment in this particular strip width. Okay, so I could say 63% of the moment reinforcement for that particular moment has to be provided within this concentrated region. And why we are doing so? Because my moment transfer from slab to column, the unbalanced moment transfer takes place within this width. So we are emphasizing more on this width in the column strip. At least half the reinforcement has to be there in this width, because this is important. So right now we are going to place 63% of the reinforcement, if you see, isn't it? Out of the total reinforcement that I place in the column strip, 63% will be placed within this strip which I have marked in orange. The code in the next clause says that it has to be at least 50%. Right now we are providing 63% of the reinforcement. Then it has provided some more clauses. These clauses you might find them similar in IS 13920 also. So in the column strip, again I am concentrating on the column strip. At least one fourth of the top reinforcement has to be continued throughout the span. So whatever maximum reinforcement you are getting, at least one fourth of it has to be continuous throughout the column strip. The bottom reinforcement in the column strip shall be at least one third of the top reinforcement at the hogging support in the column strip. So whatever you get as the hogging moment in the column strip, whatever reinforcement you get for that, at least one third has to be provided at the bottom. And at discontinuous edges, you have to provide development lengths. So this is what is written in these three clauses. These I have also written down the clause numbers over here. And then the figure, ACI has provided this figure, very easy to, I think, understand. Similar figures you get in IS 13920 also. So you can see the reinforcements and their criteria that they have to meet. For middle strip, it's simple, because middle strips as such are not going to take a lot of part in lateral load transfer. they will just act as a diaphragm system to transfer their loads to the column strips, and from column strips the uh, action will be transferred to columns. So middle strips, you just have to maintain some uh, simple reinforcement criteria. At least one half of the bottom middle strip reinforcement shall continue till the column face. Okay, and wherever you are going to discontinue the reinforcement, it has to be developed. Simple detailing criteria. So this is for the strips, the middle strip, and for the column strip. Now, what about the columns? Now, what is the important problem that you have in flat slab systems with columns? What is the main problem? The problem is that this junction between the flat slab, between the slab and column, is prone to punching failures. And as you all know, punching is a brittle type of failure, so it may lead to sudden catastrophic failures. So you have to be very careful that there should not be any punching failure at the slab column junction. And because of the lateral loads, there is an increased tendency, because of the drifts, there will be an increased tendency that the column might fail under the effects of punching due to increased drifts under earthquake. So all the clauses that we will now discuss would be focusing more on the punching criteria, and they would try to ensure that punching is averted. Okay. So very strict criteria, if you see at the critical section for punching, very important. At the critical section for punching, when you are going to check the punching ratio, you have to ensure that the shear stress should not exceed zero point 0.4 times 5 EC. So this is in the American context. In the Indian context, you could say that code is telling me that you do not have to exceed the punching stress by more than zero point 0.4 times tau c. You get it? Where tau c has to be taken equal to how much we will take tau c in case of punching. If I am talking in the Indian context, so in the Indian context, it would be what, 0.25 under root FCK, isn't it? So you could say that value, if I am using M25, will be somewhere around 1.25 newtons per mm square. So your punching stress should not exceed 0.44 times this tau c value. Understood? So this is quite a stringent criteria that has been introduced by the code, and why it is being done, so that there is no punching failure, and why this punching stress capacity is being reduced, permissible punching stress, because under drifts there will be increased stresses at the slab column junction. So that is the strategy that code is adopting. Here I have underlined that the stress that I am talking about has to be only because of the gravity load, and we do not have to consider punching stresses due to moment transfer. So I think if you are aware of flat slabs, we calculate the punching stresses because of moment transfer, and we also calculate the punching stresses because of the direct load. So here I have tried to take a screenshot from the safe software, and I have tried to highlight the shear force, if you see, and then there are some moments in the next two rows. So the moments that you see mu2 mu3 in the figure just below the shear force, these moments are the unbalanced moments. Okay, so these unbalanced moments also cause punching, they also add to the punching stress, and this direct shear force will also of course add to the punching stress. So the code in the clause earlier is telling you that you just have to take the direct shear without moment transfer. Do you understand? So basically it would mean that you take up this shear 570 kilonewtons, and you find out the punching shear stress. You just have to divide this shear force by the critical perimeter and the effective slab thickness. Very easy. You will get the punching stress, and that has to be less than zero point 0.4 times 5 EC. So this is quite a strict criteria, and this results in substantial depth requirement for slab or drops if you are going to provide them. Okay. So this is how the code is trying to avert means to negate the chances of punching. If you are not, or if you are unwilling to do so, then you have to provide shear reinforcements. So the next clause over here, it tells you that if you don't want to fulfill this criteria of limiting the punching stresses to zero point 0.4 times the tau c value, then you provide shear reinforcements. Okay, so it's an either or type of a clause. So you have to do this, and here you have to ensure that you provide shear reinforcements. I have not shown those clauses because it would take a lot of time in explaining. But there are two ways to provide shear reinforcements in punching. One is to provide the sawtooth reinforcement, and the other is to provide a beam-like reinforcement arrangement. So you provide that for this type of drift ratio. So can you see the drift ratio given to you? So if your drift ratio is such, then you have to provide shear reinforcements. Otherwise, if you are able to manage the drifts, then it's okay. You don't have to provide the shear reinforcements. So the drift ratio is given to you. If you can see for general slabs, point 0.005, or I could say 0.5%. So if you are able to control your drifts within this, then the shear reinforcement requirement need not be set. Okay. So this is how the code is treating this intermediate moment resisting frame. So basically, if I quickly uh, summarize, it is emphasizing on the column strip because that is where the lateral load transfer will take place to the columns. So there are specific reinforcement requirements for the column strip. There is a simple reinforcement detailing requirement and design requirement for the middle strip, and then there is a lot of emphasis on the slab column junction. And how that is being done, that is being done by restricting the punching permissible punching stress in concrete to zero point 0.4 times. So you are only taking 40% of the permissible punching stress, and you will size your slab drops by that uh, that provision. If not, then you provide shear reinforcements in drops or in slabs, and you try to control the drifts. So this is how the treatment is done for IMRF. I hope you understood. Yes, very good. So, what is there in the Indian context? Who knows how flat slabs are dealt with in the Indian context, especially for lateral loads? Yes, anyone knows it? So, in the Indian context, flat slabs are dealt with, or flat slabs are taken to be a big villain. So, when there is an earthquake load, flat slab is the biggest villain in the eyes of the Indian standard, isn't it? So, you are not basically allowed to use flat slabs in the Indian context in with earthquakes. I'll go to that, but before that, if you see, there is no concept of intermediate movement resisting frame systems. You just have the ordinary and the special. You don't have a system with IMRF. All right. Then, um, even more interestingly, I have taken this screenshot from IS 16700. If you notice the moment frame, it is allowing you to use a moment frame system in zone 2. This is IS 16700. So between 50 meters to 250 meters is the height of buildings that we are talking about right now. So if you see the first column number 3, moment frames are allowed up till 80 meters in zone 2. Moment frames are allowed up till 60 meters in zone 3. But in zone 4, zone 5, they are not allowing you to use moment frames. Forget about intermediate. They are not even allowing you the use of SMRFs. This is strange. I had just shown you the American code screenshot. Does anyone remember what was the limit for special movement resisting frame in different seismic design categories? There is no limit. You can go to any height in all the seismic design categories if you are using special movement frames. But here, if you see, Our Indian code is not even allowing us to use, forget about the intermediate, it is not even allowing us to use special movement frames in zone 4 and zone 5. This is quite strange. If you have a flat slab, as I told you, flat slab is considered as a villain by the Indian code. So if you have a flat slab, you have to go with a you have to accompany it with a structural wall, or what we generally call it as shear wall, but technically correct name would be structural wall. And those structural walls have to take 100% of the load, and then you also have to provide a perimeter special moment resisting frame that has to independently take 25% of the load. And then you also have to ensure that the drift does not exceed 0.1%. This is all too very strict. Okay, very very stringent criteria to satisfy. We have tried doing this, and I can tell you that it is extremely complicated procedure that has been laid out in the Indian code for flat slabs. The IS 13920 even goes a step further. It tells you, and I have highlighted these three lines in the last three rows. The adequacy of flat slab buildings shall be demonstrated by adequate, appropriate experimentation. I don't know what experimentation, how to do experimentation for flat slab, and non-linear dynamic structural analysis. Non-linear dynamic structural analysis. I do not know anyone who knows how to do this. Okay, so I don't know how code wants you to provide flat slab buildings in the Indian context. So I showed you two types of the code, how American code is treating it, and how the Indian code is treating it. Indian code is extremely conservative when it comes to flat slabs, but American code provides you a good leeway, a good, I would say, a parallel approach where you can use flat slabs with intermediate movement resisting frames. It is expected that in the upcoming revisions of 1893 13920, they will copy the IMRF system and paste it in the Indian standards also. So that is what is expected. And if you have seen, there was a discussion on the proposed amendments to IS 13920 a few months back. There they had suggested to include the IMRF system in the Indian code. Okay, so this is what I had to tell you about this. I hope you understood what I wanted to say. If you have any quick questions, if we compare R value of IMRF with Indian code, yes, so Rahul is saying the R value of IMRF in the American code was 5. Here, the R value of 5 is given for SMRF. But you should not make this comparison directly. You finally find out what is the final percentage of base shear you are getting in terms of the seismic weight. So you don't compare the R values, you compare, if you have to compare, that is, you compare the final base shear percentage in terms of the seismic weight. That is what you should do. All right. Mr. Sandeep is saying at the end of the discussion, if you kindly tell how we should find long time periods as per ASC 16, I am unable to find it. Any alternate? Oh, okay. So I don't remember because the last I used ASC 7 was almost 8 to 10 years back. He is asking about how to find out long period TN. I think it is given as 6 seconds. Long time period, but I don't remember. I will have to check. Offhand, I would be unable to tell. Then Sandeep is asking, they have given redundancy and overstrength, how it's being considered in IS 1893. So in the IS 1893, we just have the factor for R. How do we consider redundancy and overstrength? So basically, you do not directly consider it, but if you know that when we are calculating the, let's say, the probable shear capacity, the probable shear, sorry, I should say when we are calculating the shear due to ductile effects, with the help of probable moment capacity. Then, if you remember, we use a factor of 1.4. I don't know if you remember it or not. In IS 1893, we use a factor of 1.4, where we multiply that 1.4 by the summation of probable moment capacity and divide it by the span. So that 1.4 includes the redundancy and the overstrength. I mean, uh, so directly we are not considering uh, redundancy and overstrength as such. It's an indirect way that we consider it. American code has a better treatment of considering the redundancies and the overstrengths, uh, not the Indian code. Yes, good. Oh, sorry, 13920. My mistake. I should have said. Sorry. When you look at IS 13920, when it is calculating the shear, design shear, or the shear due to ductility effects, then we calculate it as per the probable moment capacity approach. There is a factor of 1.4. So that 1.4 factor has the I would say inbuilt effects of the overstrength and some amount of redundancy, but it's an indirect way of it's an indirect approach that is followed. Yes, good, good. So this is what I had to tell you. Now very quickly, we are slightly running out of time because we have an interesting guest with us today, but I will quickly go to the segment where we take up a quick project and where we discuss what we did in that project. So I'll just take it up quickly and we will have a round of discussion for it. So the project that we are going to discuss is an interesting project, I would say, where we where we were supposed to do structural audit, and it had to be done in an industrial unit, and we had to assess the as built structure. First we had to assess the as built structure, and then we had to suggest whether or not any retrofitting or any strengthening is required. So it was an industrial unit where with time there were a lot of modifications, changes, additions, subtractions. So therefore they were unsure whether the new in place whatever system they have now, is it able to take or is it able to cater to the modifications, changes that have happened over the years. So it was an automobile manufacturing unit. You can see the picture. On seeing it for the first time, you will not get a hang of it, but when you visit the plant, visit it for some days, you will begin to understand. You see a lot of steel everywhere. So we had to do an audit of uh, this industrial unit. Then, as you can see, it was a complex looking structural it was a complex looking structure with lot of steel frameworks everywhere. We had to audit it and check it, and then we had to assure its structural stability, and if required we had to provide a strengthening scheme for it. So what were the steps we I mean, in what steps we completed the project, that is what we will discuss. And in the process we will also learn how you should carry out a structural audit. So the steps that we took were the general steps that you take for structural audit. So the first step of course will be data collection. So whenever you go for any structural audit, you try to collect data. The data collection, you could do it from the existing drawings, existing equipments, existing loads, whatever you can get about the structure. You collect that data first. If you are doing a commercial building, let's say, try to collect the architectural drawings, try to collect the architectural schedules, try to collect the utilities of each and every space, whatever. Because it was an industrial unit, we collected the equipment details, we collected the existing drawings, whatever we could get our hands on, we collected that. So that would be the first step, data collection. Then you do a visual inspection. Visual inspection means your team goes to site, It sees everything with eyes. It tries to record the details which are not available in the existing drawing, or you may also try to cross check and verify the details that are available in the information that you have with what is there on the site. So visual inspection is a very important step, I would say. Then comes the preparation of as-built drawings. So suppose you have got some drawings but they are not up to date. What you see on site actually is different from the as-built drawings. Let us say because over the period of time there were modifications, changes, whatever. So if as-built drawings are not available, you prepare as-built drawings. That will be the third step. So you started with data collection, then you went to uh, then you went to yeah then you went for a visual inspection. Then you prepared as-built drawings. Sandeep is saying rapid visual survey. Yeah, but the visual surveys are not rapid. I can say that it takes time actually. It took us almost 20-25 days of 8 hours work just for the visual survey. So it takes time. It's not rapid. Anyway, then the you prepare the as-built drawings. Once you prepare the as-built drawings, then you can actually do the checking of the structure. So because we were asked to do the because we were asked to identify deficiencies, we had to check the structure. We had to sort of model the structure first as per the as-built drawings, and then we did the complete analysis design, and then member by member we checked whether or not the member is adequate, or it has some uh, deficiencies, and then we prepared a design basis and design calculation report. So checking of structures, I will say, will be the fourth step. Then in the fifth step, wherever we found out deficiencies, we tried to go for their structural strengthening and retrofitting. So we had to again do the design, and we had to come out with retrofitting schemes, and then we had to prepare drawings for the retrofitting scheme, and then we had to prepare a BOQ. So this was the process that we followed in this entire project. Very quickly, just by I will just illustrate the process by quick images, drawings, snapshots. So this is our team trying to do a visual inspection. Both of these were postgraduates in structures. So they are doing this. Then we had prepared these, I would say, simple templates to note down the details on site. So as I told you, this was part of our visual inspection. So it was not rapid. It took us a lot of time. So we had prepared these templates. So fortunately, the structure that we were auditing was typical in nature. Typical means there were repetitions. So we could make these types of templates. We would note down the section properties. We would note down the loads associated with each and every. For example, this is a triangular truss. So we noted down the loads. You could see some figures. We noted down the section properties, and then we made these templates for all the trusses, all the structural elements. So you see, this is how we are collecting the data from site. Then we prepared the as-built drawings. So once you do the data collection, once you do the visual survey, then you prepare the as-built drawings. So all these as-built drawings were prepared. So now you can see whatever we had collected on site, we prepared as-built drawings like these. Okay. Uh, and we tried to note down the loads suspended from each and every point. So whatever you see is in kg units. So if you see 1250, that means 125 kg load is suspended from this point, and so on. So we did this preparation of as-built drawings. Then, okay, so this is still preparation of as-built drawings. Then on the basis of the as-built drawing, we made this model, analysis model. For this we use StatPro. So on StatPro we made this complete model. How did we make this model? By the help of the data that we had, and the by the help of the with the help of the data that we collected from site. So that is how we made this model. And after making the model, we presented this deficiency report, wherein we tried to highlight the members which were not passing or deficient. And see, deficiency, it does not mean it is always failing. Deficiency means it is not it is not safe, it is not passing the codal provisions. So sometimes it may not pass the codal provision, but it is performing well enough, because codal provisions, as you know, are more conservative in nature. So therefore, I'm not using fail or pass. I'm using deficient or deficient or sufficient as per the codal provision. So we just highlighted the members that were deficient, the inadequacies were identified, and then after this we proposed the retrofitting scheme. So here you can see, this is, let's say, the original configuration, and then you can see some figures in magenta color. So this magenta color is what is the retrofitting or the strengthening that we have done. Okay, so this is how we made the retrofitting scheme, and this is what we finally submitted to our client. So from data collection to visual survey to making of as-built drawings, then analysis and design of the existing structure, identifying the deficiencies, and then presenting a retrofitting scheme and preparing drawings. So this is what we did, and this is what you generally do in projects which involve structural audit. Good. So this is what I had to tell you about this. If there are any questions, we will take them later, because we have a very interesting guest in the studio today, whom I would like to now invite. So we move to our third segment, which is experience sharing, and all of us learn from each other's experience. So now we would like to invite engineer Mrunmayee Kulkarni. She is a postgraduate in structures, and she is a designated partner at Innovision Consultech Enterprises at Pune. So she is a bridge design engineer, bridge engineering expert, and she is also proficient in structural assessment of bridges and infrastructural projects. So a very interesting guest, and why we invited her, because a lot of structural engineers want to become bridge engineers also, myself included, but we do not get enough chance, and we are not aware of how to enter into the field of bridge designs as a structural engineer. I am talking about. So she is one person who has done that in her career. So that's why we invite her to today's show. Thank you, Mrunmayee,
Thank you,
for
sir.
inviting us today.
Thank you for inviting me.
Yes, sorry you had to wait for a long time, I think.
No, no, your topics were more interesting, I feel.
Likewise, yeah. So before we ask you some interesting questions about how bridge engineers, I mean how structural engineers can become bridge engineers, if you could just tell us a few things about yourself. I mean, after you did your graduation, what did you do? What have you been doing since then?
Okay, so during my graduation, I was passionate about structural engineering in particular, but I didn't know which field to choose. So, fortunately, my father also works in the same industry, bridge and roads. So, I
Okay,
had a little bit of exposure of bridge engineering.
okay,
So I decided that I want to go into this field. So right from my BE project, I started working on these designs of bridges, and then I took up the elective of bridge engineering during my MTech and also during my BTech. So
okay,
after completing my BTech and MTech, I immediately joined a firm which was dealing in bridge designs particularly.
okay.
So for the past 6 years, I've been working in the same field, and from
Yes.
this year, in the month of July, we have
Ah,
started our own consultancy, me and my father. So
Wonderful.
we primarily deal in designing and proof checking of bridges and roads. So my
Okay.
expertise is in bridge, and his expertise is in roads.
Acha. Okay.
So
So
we are
together you can, yeah. So
yeah,
together
together we
you,
are
yeah,
yeah,
a good
so
team.
yeah, thank
Okay,
you.
interesting. So before, I mean, just before I ask you some other questions,
Yeah.
any project you would like to tell us which you thought in your career till now which was challenging and you were able to overcome those challenges and complete it? Any such project which you would like to discuss about?
Yeah, yeah, sure. Actually, I would say the field of bridge engineering itself is a very challenging field because every bridge is different, some or the other way. The foundation will be different, or the superstructure will be different, or the pier will be different. Everything is different, and everything is challenging. But one particular, I was fortunate enough to work on one such particular project, which was in the Pune city, which
Okay,
is double deck flyover. It is Pune city's first double deck flyover. So
okay,
on the very top tier, that the second tier, there is a metro, and on the first tier there is a flyover for our regular vehicles, and there are
okay,
vehicles at grade also. So it
okay.
is the first two-tier flyover that I designed, and it
Huh.
was challenging because the single pier was taking the loads of metro as well as the flyover
Okay.
vehicular loads.
Yeah, correct.
So there were many challenges as it was in a very congested part of the city,
Huh.
and there are some mandatory clearances which are required so that the vehicles do not dash upon the structure and hamper the structure. So
Huh.
considering all, and the metro alignment was already fixed
Okay,
because they have the alignment and their rail levels according to the station points,
correct.
wherever there is a station, according to that they decide their alignment and their FRLs. So that was
Huh.
already fixed. So we had to work on those levels, that okay, this is fixed, then we have to work keeping in the point of view of mandatory clearances, then adopting the type of superstructure or the type of pier to
Huh.
accommodate all these challenges. So
So what
if
was,
you have a time, I can show you some sketches
yeah,
to
yeah,
better.
of course, yeah, yeah, please.
Okay, just a minute.
So what was the peer-to-peer distance span?
It was 28 meters because for metro they have specific spans
Ach-
considering their rail lengths and everything.
Okay.
So 28 meter was the span for the obligatory junction, because there was a junction at grade
Uh,
which was staggered. So for those they have adopted a single span of 31 meters in between, because
okay.
we have to consider all the points, that turning radius of the vehicles which are plying on the road. So
Correct.
according to that, the middle span was 31 meters and all other the spans were 28 meters.
98 meters.
Yeah. So I'll quickly show some images to better
Yeah, of
understand.
course. Yes, please.
Okay, so can you see?
Not right now. You have a present option.
Yeah, yeah, yeah. I have clicked on that. Just a minute. I hope you can see now.
Now I can see. Yes.
Yeah, yeah.
Oh,
So
okay.
this is the photograph which shows that there is a traffic on the road. Then there is a middle tier, and then there is a top tier on which metro is lying. So I won't go into the salient features, but as I mentioned, the obligatory spans were 28 meter, 31 meter, and 31 meters. This is the typical plan and elevation of the flyover.
Right.
There were two systems of pier cap which were adopted because we wanted a mandatory clearance. So as you can see here in the right image, we had adopted inverted T pier cap so that we would get maximum clearance below the pier cap.
Oh, okay.
Normally in bridges you see hammerhead types of pier caps.
Ah, correct.
There the entire depth of pier cap is below the pedestals,
Correct.
which increases and as the pier cap supports two different carriageways on each side,
Ah,
so the loads and the loads were quite huge. So if
Yeah.
we had gone for the conventional pier cap, then the depth would have come around 2 meters or 2.2 meters, and then it would have reduced the clearance from the road.
Ah,
So we
correct.
had gone for this inverted T-shaped pier cap, which was pre-stressed pier cap.
Okay.
And additionally, what we did is to further maximize this mandatory clearance criteria. What
Ah,
we did is we had adopted superstructure as uh, steel plate girders. So
okay.
we reduced the depth at the ends, and we kept the maximum depth at the center where the moment, because all the girders were simply supported, the
Ah,
maximum depth would be required at the mid span.
mid span
So we reduced the
at the
depth at
ends.
the edges. Yeah. So
Understood. Yeah.
these are the photograph. This is the photograph of that inverted pier cap, but this is a construction stage. So this is not the full length of the cap,
Yes.
because they wanted to construct the metro first, because they have further track laying and electrification
Ah,
and everything. So
yeah.
they wanted the pier to be cast first, the pier which was above the flyover.
Ah,
So we casted the pier caps in stages.
ah,
So this is the construction stage photograph of the inverted TPR cap. So this is the 3D view to get an idea. As you can
yeah.
see here, the depth of the superstructure is less at the edges and maximum at the center. So
Correct.
this helped us in reducing that clearance, the maximum depth, and thereby increasing the clearance from the road.
Understood. Yeah.
Yeah, yeah. For the as we go on the approaches, in the ramp portion, the height decreases eventually. So to
Ah,
economize, we for those particular spans where the criteria of clearance was not there, we adopted the normal conventional hammerhead type pier caps, as you can see here.
acha.
So as I already mentioned, the challenges in the superstructure and deciding the type of the pier cap. One more challenge we faced was of the utilities which were already there below the road surface, because it is
Yeah.
a very congested type of the flyover is in a very congested area. There were a lot of utilities which were the contractor was not able to shift those utilities in some portions, so we had to modify the pile cap shape and the distances between the piles to accommodate those utilities as well.
Okay.
So that, yeah, so that was the biggest challenge. So these are the challenges we
Challenges
faced.
you. Oh,
Yeah, yeah. So
wonderful. So this is
the yeah, it was open to the traffic on 13th March 2022 this year.
wonderful. Very nice. So what is the total length of this?
Total length including ramps is 536 meters.
Acha. Okay.
Hmm.
But it's a small bridge then.
Yeah, yeah,
536
it's a very
meters.
small bridge. It was just to bypass that staggered junction, because
Okay.
on that particular stretch of the road, the traffic is very huge,
Okay.
approximately 40,000 vehicles per day in the peak
Oh,
hour. So just
acha.
to bypass that particular junction, they had proposed that bridge.
So do you have, I mean, because Indian standards, there is this problem that because this was not a regular structure, do you have enough updated IRCs to take up these types of structures, revised
Yeah,
IRCs?
because only the analysis part was a bit different, I would say. And
Okay.
also, railways has their different codes, IRS codes.
Ah,
So we used the combination of IRS and IRC codes, because it
okay.
was supporting the metro rails. We had to
Ah.
use the railway standard codes, because
So,
there.
sorry,
Yes, sir.
please continue. Yeah, please continue.
Yeah, so for the design of that particular pier, which supported both the decks, the flyover and metro, we use the IRS codes to design that pier.
Okay.
And for superstructure of flyover
Ah,
and all other components of that bridge which were pertaining to the flyover, we used IRC codes, because the design
yeah,
procedure was
understood.
same. Only
Same.
the analysis part was a little difficult.
Okay. No, so you talked about the inverted pier cap,
Mhm.
pre-stressed inverted pier cap. So there are IRC codes for that, those types of structures available.
No, IRC code does not specify the procedure based on the shape of the structure.
Okay.
So the behavior of that particular pier cap was just as a cantilever.
Huh. But there are
Only
no
the
specific criteria or clauses given
no,
in.
no,
Okay, okay,
no.
okay.
There are no specific criteria. It was just designed as a cantilever pier cap,
Acha.
and we use the softwares for analysis, and then design was done in normal manual method.
Okay. Very interesting. I must congratulate you for doing such a
Thank you
wonderful
so much.
project.
I was just a part of that project. There
Yeah, but
were many
of course,
intelligent minds behind it.
of course. So one thing that we always wonder, and you could throw some more light on it, that and there are already questions from the audience for that. And yes, one thing for the audience, you may type in your questions. We would take up with Mrunmai, or if there are any questions for me, you can type in them also. So one aspect which structural engineers, we as structural engineers often complaint is that we do not know how to design bridges. So we are never taught either in graduation. Graduation it is okay, but even in post graduation we are not taught how to become bridge engineers.
Yeah, that's the most unfortunate part, I would say.
Yeah. Yes. So if you could guide us that as a fresh structural engineer, or not even fresh, even practicing structural engineers, if they want to diversify into bridge engineering, what is the primer for them? What how
Okay.
do how can they make the switch? If you could tell us a few things about that.
Yeah, sure. So, uh, in my opinion, that I do not have the experience of buildings, but in my opinion, the basis of structural designing remains the same, be it any structure, be it a building, be it a bridge, be it a silo, anything. The basic ideology or phenomenons or the loading pattern remains the same. The only challenge is how to design and what criteria are taken into consideration while designing that particular structure.
Yes.
So I would share a presentation, and I would just guide everyone, uh,
Ah,
as in what to prepare and how
correct.
to approach this particular field.
Okay. Yes, that would be great. I think that will answer a lot of questions that we have in our mind.
Yeah, just a minute. I
So
hope
should
you are
I?
able to.
Yeah. Yeah. Yes.
Yeah, yeah, okay. So for designing any particular structure, the main thing we have are our codes, Indian standard codes or ACI codes or Euro codes. So before studying the course, you should know the basic terminologies that are used in that particular field, in the field of transportation engineering or bridge engineering. So I would say before entering the field, you must do some background studying so
Ah,
that it becomes easier for any, be it a fresher or a practicing engineer, it becomes easier to get into the field and to get the knowledge of what is going around you.
correct.
So getting acquainted with the specific terminologies that are used in this particular field would be your step 1.
Yes.
Then basic study and structural behavior of different components, like in bridges there are various components: foundation, then abutments, how abutments behave, what kind of loads abutments take, what
Ah,
is the purpose of that particular structure or that particular component. That would be your step 2. So piers and bearings are very essential component. It is often said that bearings are the lifelines of the bridge. If there is any distress in the bridge, the first and foremost thing you should do is go check bearings.
ah,
So bearing is a very important part, and we know very less about the behavior of the bearings, and there are different types of bearings used for different types of structures.
ah,
So bearings in superstructure, then what is wearing coat, what are different types of wearing coat, then anti-crash barriers. These are the basic components of the bridges. So you should have the basic knowledge about the working of these particular components.
yes.
Then comes the code. The codes are just the basic guidelines uh, decided by our Indian Roads Congress to give you an idea and to guide you through the process of designing a structure. So these are some of the codes which I have mentioned here. IRC5, this code gives you a general features and general terminologies, definitions of various components and terminologies used in the field of bridge engineering. Then there is IRC6, which is the code which gives you loading, just like IS 875, which
Oh,
gives you the loading, what loadings are to be considered, what are their specifications, criterias, limiting values,
correct.
etc. So basic loading, which is governing in this particular structure, is live loading. So
Oh,
IRC 6 has laid some rules and idealized vehicles and given
oh,
that loading. So this loading you have to consider on your bridge, and to get the idea of how your structure behaves when a vehicular load passes through the structure, you must have some idea about influence line diagrams, which we learn in BE, then we
oh,
forget. But if you want to enter in this field, you should know what are influence line diagrams, because influence line diagrams are essentially for variable loads.
yeah.
So you should have that particular idea. Then IRC 112, this code gives you the guidelines for limit state design of the structure.
Ah,
Earlier, bridges were designed by working stress methods. In
correct.
2011, this new code came, and the revision has also come in 2020.
Okay.
In 2011, Indian standards switched from WSM to LSM.
Oh,
So this code is for that particular those particular guidelines.
oh,
Then recently they have introduced a new code for seismic design, because seismic design has uh, a very important part to play in the design of structures.
yeah.
Because now even for buildings and bridges, they have made some stringent criterias to design the structure for seismic loadings. So
Yes.
earlier the seismic loading was a part of IRC6. Now
Ah,
they have a separate code dedicated to seismic design of bridges.
okay.
So
So this
that is,
covers all types of bridges, steel,
yeah,
RCC.
yeah. It just covers the loading,
Acha,
and
it
then
covers
it covers the loading, and for designing, for RCC you'll have to follow IRC 112, and for
understood.
steel structures you have to follow IRC 24.
24. So they have taken out the seismic from IRC6 and put it
Yeah.
into SP11.
Different code. Yeah, it gives you the ductile detailing part and everything in detail basically, and they have some solved examples also for
Acha.
the interpretation of those clauses, because
Okay.
sometimes that becomes a very tedious part, how to interpret something from the code.
Yeah.
So to make it easier, they have given some solved examples and everything. Because in these structures, base structures, the stiffness of the structure changes from
Oh,
foundation to superstructure, because there are bearings in between. So the
correct.
stiffness is different. So idealizing that stiffness and then calculating the time period is a tricky part.
Okay.
So that's why they have come up with a new code,
Understood.
which gives you guidelines for different types of bearings and stiffnesses of the structure.
Okay.
Then for bearings, there are many types of bearings. Bearing
Oh,
is a link between superstructure and substructure,
yeah.
which takes all your forces, horizontal, vertical,
Yeah.
movements, everything. So IRC 83, it has four parts. So it deals with the bearing part. And then IRC 78 is the code for foundation. These are the
Oh,
basic codes. There are many codes and special publications of IRC, which
oh,
deals with the smallest components which are used in bridges.
okay.
So these are the need to knows. Basically, you need
Ah,
to read these particular codes to understand what you will be dealing with if you want to enter into this field.
right.
Then you should know basic behaviors of different types of bridges. There are the categories of bridges, like arch bridges there. Then there are culverts, box culvert,
Ah,
slab culvert. Box
ah,
culvert is a complete rigid box, and how
ah,
that behaves, how's the deflection pattern, how the bending moments. Then there
yeah.
are different types of superstructure, namely PSC girders are there, then truss girders are there,
Ah,
plate bridges are there, plate girder bridges are there. And
yeah.
now there is a trend of long span bridges.
Ah,
So mostly we go for steel structures, or there are advancements in the concrete as well. There
ah,
is ultra high performance concrete, Then there is a new innovation in the steel also. They are using GFRP, glass fiber
okay,
reinforcement.
okay,
So you need to know basics of how structure behaves with these different types of materials.
right.
Of course,
You
you'll
can
get.
just you can just press the hide button over here. You are seeing a hide on the screen. Just
Yeah,
look
yeah,
at your.
yeah, 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 yeah. Okay, okay, okay.
Just press the hide button. Yes, yes. Okay.
Now,
So
a bridge is a type of structure uh, which deals with multiple disciplines. You
yes,
need a basic knowledge of transportation engineering, highway engineering, then geotechnical engineering.
right.
So, one such area is hydraulic studies.
Correct.
In the recent past, we have seen some failures
Uh,
for which the wrong hydraulic design is a major part. So,
okay.
studies on hydraulic calculation is a major part of uh, designing any bridge which is over river.
Uh,
So, you must have the knowledge of hydraulic studies and hydraulic calculation. Of course, everything is given in codes, but the
uh,
interpretations and studying the local area and local hydraulic HFLs and everything you have to consider. So, you must have a basic idea about hydraulic calculations.
right.
Then, as I said, it is a multidiscipline area.
Mm,
You should know how to read a topographic survey, because many a times structural engineer, the bridge design engineer, deals with structures which are on national highways, state highways.
uh,
Structures is a part of that particular project. The
correct.
widening of highways or national highway, construction of new highways.
Uh,
So to design a structure plying on that particular highway, you should know how to read a topographic survey of that area.
yeah.
What features are to be considered while designing a structure.
Uh,
So that becomes, of course, you don't need in-depth knowledge. You will gain that knowledge along your journey.
yeah.
But before entering the field, you should have some basic knowledge on how to read a survey, how to read a
Uh,
contour survey, how to read a topographic survey.
uh,
Then there are, as I said, many a times the structures are on highway. The major quantum of the structures are on highway,
uh,
the widening of existing highway or the new highway. So
yeah.
some parts of transportation engineering, like what is a plan and profile,
Uh,
what is the super elevation,
uh,
and what type of pavement they are using for roads, because
uh,
that defines what type of wearing coat you are going to provide on your bridges. So
correct.
these particular small terms you should know, because that will just enhance your uh, image if you
Uh,
are going to enter in this field, and if you're going for an interview and you already know all these things,
uh,
then you have something plus than the rest of the candidates.
correct. What is PCU?
PCO is passenger car unit.
Acha, PCU. Okay, okay. Yeah.
Hmm.
We used to call it by a different name. Passenger.
Okay.
I don't know. PC.
I
P.
think generally it is called PCU only, passenger car
Acha.
unit. It is just the idealization of traffic in.
Ah, I understood. Yeah, yeah.
Yeah,
Yes. Please go ahead. Yeah.
yeah, yeah. So I think you have covered the topic of geotechnical engineering in your previous episodes. So
Ah,
that is a very important area, because
correct.
ultimately it defines the quality of your design
Ah,
and quality of how good a structural engineer you are. So
yes.
interpreting geotechnical reports and being well versed with the terminologies used in those reports, like RQD, then what is the unconfined compression strength and everything, what is SBC, how SBC is calculated if there is an open foundation, if there is a pile foundation, how pile capacities are calculated.
Ah,
So these basics of geotechnical engineering you must learn.
ah,
And I think your platform is providing a very good support to the people who are eager to learn these kind of things.
thank you. Thank you.
Then uh, then learning to read the drawings,
Yeah.
then visiting sites. Yeah, so you should, uh, I would say, uh, there is so much development going around in all our surroundings.
Ah,
Every now and then there is some new plan of for bridge or elevated corridor, something like that. So you should know what is going around in your area, and you should visit more sites to get to know how a structure looks, because that's the visualizing what you're designing
Huh.
is very important to uh, know how the structure is looking, how the structure is behaving, and what is the purpose of that particular component you're providing or you're designing.
Yeah.
So the more you sites visit, the more you visit the sites, you
It's
get to know different kinds of uh, technologies or different kinds of foundation, superstructure that is used in that particular structure by some other designer. So
correct.
it enhances your knowledge. The more you
Yeah.
the more you visit sites, it becomes a plus point for you. Then we use my nowadays we use Midas Civil software for designing bridges. It is a very versatile software.
Huh.
So there are many courses available
Huh.
to learn the basics of Midas. Then there is TAD Pro, MS Excel, and AutoCAD. You must know at least these three softwares before entering the field, because
Yeah.
even now most of the design part is done manually in MS Excel.
Acha.
So you must have a very good knowledge of Excel before entering the field, and AutoCAD,
Yes.
because many times engineers become draftsmen and
Yeah.
draft drawings because we have so many limited resources in this field.
Yes.
So yeah, AutoCAD, STAAD Pro, and MS Excel is a must before
Right.
entering the field.
Very interesting.
And as I said, keeping in touch with advancements in the field via LinkedIn, newspaper, seminars, and paper presentations. So much goes around us.
Huh.
So keeping in touch with these advancements in the field is a plus point. Then after entering the field, you can get a memberships of Indian Road Congress, then Indian Institute of Bridge Engineers. They have seminars from time to time, and they have their own journals also, which has
Okay.
papers from eminent personnel in the field.
Yeah.
So that could give you an idea and enhance your knowledge. You could get acquainted with new materials coming in the field, which designer, which consultant is uh, doing what in the field, the new thing he's doing. So yeah, these are three basic institutions, that IRC, Indian Institute of Bridges, and Indian Institute of Engineers.
Engineering.
Yeah,
Interesting.
you can just get a membership. The lifetime membership is there available in on those
Okay.
platforms.
Okay.
So yeah,
Oh,
these are just the basics. So I
yeah.
hope some of our viewers will think of coming into this field.
Yeah. It's very interesting actually. There are a lot
Yeah,
of
field is
questions
very
people
interesting.
are asking.
Yeah, yeah, sure, sure. So I'll just end the presentation.
No, no, you can keep the
Okay,
presentation on.
okay,
Maybe some questions are on the presentation.
yeah.
So, yes, audience, you can ask questions. You can ask uh, Mrunmai, or if you have questions for me, you can ask them, and we will be happy to answer to your queries. So, Sandeep is asking, uh, okay, so he has a complaint that why bridge
Yeah.
engineers out there are afraid of teaching the subject to others. Uh,
I would say they are not afraid, but as they have very limited resources, they don't have anyone to help them, so that they get a chance to and they get time to teach someone else.
yeah, you should start a course on bridge engineering.
Yeah, sure, sure.
Then his complaint goes on. He's saying he has heard from industry professionals who are designated as bridge engineers, that is senior engineers, but they hardly get any core work to do, and they are left to prepare BOQs for 5 6 years.
No, I cannot say anything on, on this particular complaint, but yeah, sometimes this happens. If you go into big companies and you
Yeah.
have a limited knowledge, then you're given a particular work, and then you get mastery on that work, then you are given that particular work for
Right.
the rest of your life.
Yeah, that happens. Then Mr. Rais Bhatt is joining us from Srinagar. He is asking for beginners how to become practicing bridge engineer. So I think your presentation has covered
Yeah.
a lot of things about it. Uh, okay, so Rahul is saying in code, IRC codes, that is, design of wing wall of the abutment is not very clearly given.
Okay. So wing walls are essentially retaining walls that are just given in angles.
Yeah,
Normally nowadays it is a trend that no one goes for wing wall because it requires a huge area and land acquisition is nowadays a problem. So if you
yeah,
want to design a wing wall, it is essentially a retaining wall. So you have to consider forces according to retaining wall. But
mm,
as it is inclined in plan, you have to resolve those forces and take that into consideration.
correct.
And if you want to learn more about wing walls, it is given in IRC 78, the basic
70.
concept. Yeah.
Okay. Then yes, very important question. Good books. If you could recommend some good books for
Yeah.
reading and knowing more about bridge engineering.
Mhm. There is a book by, I don't remember the title, but the author is SP Bindra.
Okay.
It is about bridge engineering, and he has covered design of each and every component, right from deck slab and the basic things like there are some intricate details and how to consider the live load. So he has
Ah,
covered that. Then there is one book from the author Johnson Victor.
okay.
That is also a very good book. That is a
And
very yeah. And for different topics like pre-stress or everything, Krishna Raju sir has written a book on pre-stress bridges. The
mm,
concept remains the same
correct.
of pre-stress, but how to implement that into bridge structures,
Ah,
that becomes a tricky part. So yeah, to start off with, you can use SP Bindra,
ah.
bridge designed by SP Bindra. I think
Yes.
that is the title. Yeah.
Softwares, I think you have already told in your
Yeah, I've
presentation.
yeah, I have primarily used StadPro and Midas.
Okay. Interpretation of code is also a skill. Sometimes we do not know a particular clause and what it has to tell in the
Yeah.
code. I think that is a big problem.
Yeah,
Yeah.
that is a big problem. But IRC has come up with a solution. They have published an explanatory for
Oh,
IRC 112.
acha.
Because when IRC 112 came into, when they published IRC 112, the concept of limit state for bridges was very new for
Ah,
practicing engineer. Because for many years, we were designing bridges by WSM. Even in BE, I learned the design of bridges by WSM method only.
correct.
Then later that LSM code was that LSM code came into picture. So they have published one explanatory.
Ah,
So in that explanatory, they have given interpretations and solved examples. The explanatory is IRC SP105.
acha. I think IRC is much more active in revising and coming up with explanatories, new codes. BIS has gone to sleep, it seems, because
Yeah.
IS codes are not getting revised.
After 2000, I guess new
Yes,
revision has
gone
not
to
come.
sleep. Yeah, IRC is much more active, I guess.
Yeah, yeah. Even in the Indian Highways Journal,
Uh,
they publish a journal every month, Indian Highways, and
okay.
whatever queries they have received from practicing engineers, they
Uh,
try to amend those codes, those
oh,
particular codes, and those amendments are given in the last on the last pages of that particular journal. So
okay.
even if you are following that code, you have to keep in touch with these particular journals that whether some new amendment has come. So they have revised some load factors in the amendments and everything, the interpretation of clause, they have removed some clauses
Uh,
because every time they cannot publish a new code with
yeah,
new every year. So
correct.
they publish these amendments
Uh,
time
Real
to
time
time.
management is happening. Real
Yeah.
time, every edition of the journal. Yeah. So
Yeah.
can we also get membership of IRC, or there is some
Yeah. No,
work
there is
experience?
no, there is no criteria or eligibility. Anyone
Okay.
can get a membership of IRC.
IRC. Yeah. Okay. Kashyap is saying design of different type of peer or multiple peers supported on a peer cap. In which text do we get this information?
Unfortunately, you won't get it in any text. You may read some papers
Uh,
by some authors. You'll have to search for those particular structures or case studies
yeah.
because textbooks don't cover each and everything which we do in practical. So yeah, you'll have to search for some case studies.
Uh, Ajay ji is asking which theory is used for analysis of bridges.
Which theory, as in?
Theory means for analysis. How are you? So right now, I think the analysis is happening all FEM based, matrix
Yeah, yeah.
based analysis
An
methods.
elastic theory.
Okay.
Inelastic analysis is not yet for major bridges, and for some critical bridges they are doing inelastic analysis also.
Okay. Okay.
But usually elastic analysis is full.
Uh, Naveen ji is asking, can you suggest code for structural retrofitting of bridges? Yeah, here I would just ask you because you are also good at the assessment surveys, carrying out assessment surveys. So if
Hmm.
you could just tell us that what exactly do you do quickly in an assessment survey?
Okay, so this is a new avenue which
Okay.
is open, and it will gain some speed because most of our inventory of bridges was constructed in the year either it was constructed in the British era or
Ah,
in 60s or 70s. So these
yeah.
bridges are nearly at the end of their design life.
Ah,
So rehabilitation of those bridges is a new avenue that you can pursue. So
ah,
basically, what we do is the first step is visual inspection, as you have already
yeah.
described in your slides. So visual inspection plays a very big part
Yeah.
in assessment of bridges.
Correct.
Then after visual inspection, and visual inspection shall be done twice. We usually do it twice. Once in dry period and
Ah,
once in monsoons, because in
correct.
monsoons you know the actual problem due to leakages or due
Yes.
to the high flood levels and everything. Then
Yeah.
after visual inspection comes the identification of problems.
Okay.
Most of the bridges which we have retrofitted or rehabilitated are from the British era. So
Ah,
in those particular bridges the main problem is of vegetation and
mm,
loss of contact between the stones. The
ah,
pointing or the plastering is loose. Otherwise structurally those bridges are sound, but these small problems lead to big disasters. So
okay.
identifying those problems, then if there are major problems or settlement issues or crack issues, then you'll
Ah,
have to give a proper methodology to rectify those cracks. So jacketing is there, carbon wrapping is there
ah,
to enhance the capacity, and first you have to close the cracks by grouting, and then to increase its structural capacity there is carbon wrapping and jacketing. Mostly jacketing is done because it is economical.
so
But
once you do this, then how many years have you added to the life of the structure?
it varies from structure to structure, but at least that bridge can survive up to 30 years.
Acha, 30 more years.
Yeah, 30 more years.
Good.
If it is a
Very,
stone masonry bridge, then the life is much lesser because you have to go for another option.
yeah.
But if it is a RCC pier, then the life increases by 20 to 25 years, 30 years in most cases.
Yeah. Uh, Abdul Asad is asking, CSI Bridge, have you used that software? Any experience of using that?
I have not used that software, but many practicing engineers use this software for designing CSI bridge.
For steel bridges, any book if you can recommend?
Book for steel bridges. I'll definitely get back to you on this. I'll
Okay.
share it in the comments. I don't remember as of now. I'll
Okay.
share it in comments.
Then I think this is for me. In the design procedure for bearing plate, is it same for I section and hollow section? I am not able to find the design procedure for hollow sections resting on bearing plate. I think the overall procedure will remain the same, just that you will have two web plates to take the bearing stresses or the reactions that come from the bearing plate. So in I section we only have one web plate to check the strength. Here we will have two web plates. So in my opinion, you can just half the reaction from the bearing and you can divide it on the two webs of the hollow section, and then you can proceed with the simple checks that are given in our codes. I at least do it this way. Otherwise, there is no specific and a different method given in any of the text for doing this. Very interesting. Uh, why health monitoring techniques are less popular in India? collapse of suspension bridge located at Morbi, Gujarat.
Yeah, this is the hot topic. Actually, health monitoring techniques are not less popular. There are many uh, what we can say instruments which are being placed at some bridges to monitor the deflection and any other criteria which a structural engineer desires. And there are mobile inspection units, then there are inspection units which are already built in the bridges. So these health monitoring techniques are not less popular in India. I won't say anything about the Morbi bridge. It was a very unfortunate incident. And
Yeah.
if you want to know more about this particular failure, there is one video of, I guess, Mr. Atul Bhube. He interviewed it on NDTV, I guess. So he has explained it in detail. What were the
Okay.
factors involved in the collapse of that particular bridge?
Mm. Yeah, not notwithstanding this failure, but you are also on that WhatsApp group where every other day
Yeah.
some images come
Yeah.
where there is a under construction part of
Hmm.
the span that just collapses. So why are these collapses happening so frequently these days? Of course, people are not losing life, but under construction spans are just falling down, or maybe during erection they are falling down. What's happening?
I think it is a combined problem. The contractor is also at fault sometimes. The designer is at fault, or sometimes the authorities which decide. The See, there is a tendency of giving the project to the lowest bidder.
Yeah, L1.
So that is the most. I think that is the biggest problem here,
Uh,
because the allotment of the project is based only on his quoted lowest price. And I think the experience of that particular contractor or designer or any other who is working on that project and who has bid must be taken into consideration, and not just the lowest price.
yeah,
So
correct.
if a contractor has quoted a very less price than the project cost, then he
Uh,
tries to save some
on
amount in something or the other, and this leads to the collapse of the structure, under construction structures.
Yeah. Then Abdul Asad is asking, how about bridges? Huh? How about? I think he is asking bridge analysis
Overseas and Indian.
overseas.
Huh.
How is it
I have
different?
not
So,
yet designed a structure which is not in India, and the overseas structure I have not
no,
designed.
no,
But
not
there
overseas. No, no, not
hmm?
overseas. He is
Okay,
asking the sea,
overseas.
Samudra,
Okay,
on
okay, okay,
the
okay.
Samudra. Yeah.
Oh, sorry, sorry. So it is not different, but the loading pattern is different. I guess there is a standing water in bridges. Then you have to consider the effect of tides,
Uh,
high tides and low tides. Just
yeah.
some additional forces you have to take into consideration
Yeah.
when you are constructing a bridge in sea and in on the normal river. And also the exposure condition is different. Marine environment you have to take into consideration while designing, and detailing of the structure is important when you're designing it on sea.
Correct. Very interesting. So, audience, any more questions we have? So I think we had a very good discussion with you, and
Thank you.
lot of good things to learn from you today. I think we all can at least start by taking the membership of IRC for
Yeah. That can be
this
a very first step, so that
yeah,
you will be in constant touch with the field.
field. And yeah, I just wanted to ask you that what are the proof checking mechanisms in these designs that you do? Because most of them are government projects, so you have
Yeah.
to get it proof checked. So what is
Most
that
of the
mechanism
times,
that
yeah,
works?
there are different agencies also, just like a design consultancy. We
Ah,
also do the projects of proof. We also provide a consultancy for proof checking of bridges.
correct.
Sometimes it is written in the contract that your projects have to be proof checked by some Indian colleges like IITs or
Ah,
government colleges. So
right.
it depends on the contract and depends on the type of the project.
Ah,
So many a times there are consultancies which do the proof checking work, like private consultancies.
okay.
Either contractor appoints them or the government appoints them directly.
Ah,
And
so,
sometimes it is written in the it is mandatory to get it proof checked by IITs.
okay. But are they competent enough? That is a
Yeah.
different. Acha. Okay. Good. Very interesting. So I think we have come to a close of questions that we had. There's no question left. So anything, any parting message that you want to give us to the audience?
I just hope that I have I am successful in inspiring some of the people to come into this field, because it is really a very interesting field, and it's very unfortunate that we don't get to learn these kind of things in our regular curriculum. Not only bridges, there are so many different structures, like I mentioned silos, then there are nuclear power stations and everything, which we do not get to learn into our regular curriculum. We just get to learn the basics of structural engineering. But
Yeah,
if you want to diversify your career, you should think of these options.
right.
So I think more and more facilities should be provided at college level also.
Ah,
Like in our college, in my BE, we fought with our professors
okay.
just so that we get an elective of
Yes.
bridge engineering,
Acha.
and we were
We had
successful.
we, no, we had an elective, but that elective was never offered to the students.
Yeah,
In
most of the times this happens because they have a limited resources in terms of faculties which deal with these subjects.
correct.
So yeah, we made our college give us that faculty in
That's
our last year BE.
okay. I think grillage analysis, Kashaf is asking, will be included in design, and for curved type of bridges, what do they do? Curved in plan,
Yeah,
I
most
think.
of the times they do for very simple structure. We go for line analysis, 2D analysis. Otherwise,
Yeah.
almost every structure for every structure we do the grillage analysis itself.
Okay. So Sandeep is saying he has started working on the uh, power plants. So he has
That's
diversified,
interesting.
and
Yeah,
from buildings he has started working on power plants. Very good.
that's amazing.
Akash is saying, he's asking which component of an RCC bridge gives the first distress signs of failure. Which element should fail first in the event of an earthquake? So, are there any capacity based approaches that we have in our general buildings that we like to initiate ductile failures in our structures,
Yeah.
uh, not the brittle failures? So, I think his question is that what are the ductile failures, modes of ductile failures you can have in your bridge structures? I think that is what he's trying to ask.
Yeah, so as I mentioned, they have a separate code for seismic analysis nowadays, IRCSP 114. So that code deals with these particular aspects of seismic failure. So we identify the locations of plastic hinges,
Okay.
and in those zones, the stirrups for pier, the
Ah,
stirrups spacing is reduced,
correct.
and there are even for response reduction factor also, they
Ah,
have different criteria based on different zones and
acha.
type of bearing you're using for the structure.
Right.
So identifying the plastic zones and providing more reinforcement in those zones, you can you can guarantee that the ductile failure will occur for that particular pier. So
Okay.
there is you cannot say that which component gives the first sign of failure, because it depends on what kind of failure is that. So if there is a settlement of foundation, then you'll see the crack in pier.
Ah,
If you're and also if there is a failure of bearing, you'll see the effect in piers.
ah,
So most of the times to assess, you should look closely to the piers and the bearing part. If there is sagging, there is a capacity failure of girders, you'll see you can visually see the deflection in the girders.
fracturing the
So
girders.
what
Correct.
type of failure is there in the bridge? The different component will give its indication.
Correct. Very interesting. So I think we have come to an end of our episode. So if there are more questions, you can always connect with Mrunmai. She has already given her email ID in the presentation. You can just connect with her over mail, and I'm sure she would be happy to answer to the queries. Acha, okay, so Sandeep is telling us about the power plants he is working on. Very good. Okay, so thank
Okay.
you, Mrunmai, for joining
Thank you
and
so
taking
much
out.
for giving me this opportunity
Yeah,
to
and
tell something, 1% of what my field represents.
yes, So thank you for taking out time on a weekend, and thanks to everyone for joining us today. So until we meet next time, it's goodbye and enjoy your weekend and have a good time. We will now meet you in the first week of December. So bye bye. Good night.